new information concerning Venus. The Venus flyby reveals low-frequency radio signals have been detected in the planet's atmosphere. During a close flyby of the planet Venus in July 2020, NASA's Parker Solar Probe detected something very odd. As it dipped just 517 miles above the Venusian surface, its probe instruments recorded a low-frequency radio signal, a telltale sign that Parker had skimmed through the ionosphere, which was a layer of the planet's upper atmosphere. This is on Science Alert by Michael Starr. Now, this was the first time an instrument had been able to record and direct in situ measurements of Venus's upper atmosphere in nearly 3 decades. And the data recorded gives us a new understanding of how Venus changes in response to cyclic changes in the sun. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. I was just so excited to have new data from Venus. This is what astronomer Lynn Collison of NASA's Goddard Space Flight Center said. Venus is a fascinating world to us here on Earth. It's so similar to our own planet in size and composition, but so crucially different. It is toxic, has a scorching hot hell world that's likely completely inhospitable to life as we know it. Now, how the two planets could have developed into such radically different beasts is of deep interest to planetary scientists and astrobiologists searching for other habitable worlds out there in the Milky Way. Yet missions to explore Venus have been relatively few, and there's not much point sending landers. They can't survive the planet's huge 864-degree Fahrenheit surface, or 462 degrees Celsius. So sending orbiting probes is also considered problematic due to the incredibly thick atmosphere of carbon dioxide and sulfuric acid rain clouds that make it hard to tell what is happening on the Venus surface. For these reasons, Venus has not been a popular target for dedicated missions in some time, Japan's Akatsuki orbiter being the recent exception, and a lot of our recent data has come piecemeal from instruments with other primary objectives like the Parker Solar Probe. As Parker conducts its mission to study the sun in close detail, it's being used using Venus for gravity assist maneuvers, slingshotting around the planet to alter velocity and trajectory. It was one of these gravity assist flybys that the probe's instruments recorded the radio signal from Venus. Collison, who has worked on other planetary missions, noted an odd familiarity that he could not quite place in the shape of the signal. He said, "Then the next day I woke up and I thought, oh my God, I know what it is. It was the same kind of signal recorded by the Galileo probe when it skimmed through the ionosphere of Jupiter's moons, a layer of atmosphere also seen on Earth and Mars, where solar radiation ionizes the items, resulting in a charged plasma that produces low-frequency radio emission. Once the researchers realized what the signal was, they were able to use it to calculate the density of the Venusian ionosphere and compare it to the last direct measurements taken all the way back in 1992. Fascinatingly, the ionosphere was an order of magnitude thinner in the new measurements than it was in 1992. The team believes that this has something to do with solar cycles. As we know, every 11 years the sun poles swap places, south becomes north and north becomes south. It's not clear what drives these sun's cycles, but we do know that the poles switch when the magnetic field is at its weakest. Because of the sun's magnetic field controls its activity, such as sunspots, which are temporary regions of strong magnetic fields, solar flares, and coronal mass ejections produced by magnetic field lines snapping and reconnecting. This stage of the cycle manifests as a period of very minimal activity. It's called the solar minimum. Once the poles have switched, the magnetic field strengthens and solar activity rises to a solar maximum before subsiding again for the next polar switch. Measurements of Venus from Earth suggested that Venus's ionosphere was changing in sync with the solar cycles, growing thicker at solar minimum and thinner at solar minimum. But without direct measurements, it was difficult to confirm. Well, guess what? In 1992, measurement was taken at a time close to solar maximum, the 2020 measurement close to solar minimum. They were both consistent with the Earth-based measurements. When multiple missions are confirming the same result, one after the other, that gives you a lot of confidence that the thinning is real. This is what astronomer Robin Ramstad of University of Colorado says. Exactly why the solar cycle has this effect on Venus' ionosphere is unclear, but there are two leading theories. The first is that the upper boundary of the ionosphere could be compressed to a lower altitude during solar minimum, which prevents atoms ionized on the day side from flowing to the night side, resulting in a thinner night side ionosphere. The second is that the ionosphere leaks into space at a faster rate during solar minimum. Neither of these mechanisms could be ruled out by the Parker data, but the team hopes that future missions and observations might be able to clarify what's going on. In turn, that could help us again gain a better understanding of why Venus is the way it is compared to our Earth. Maybe it's about time for another Venus mission. The research was published in Geophysical Research Letters from NASA, and this is on Science Alert. Please leave your comments, and thank you for your support.